So the next phase in this project is to work out the photoresist process. The photoresist that I'm using is a UV curable solder mask, or it's also known as solder paint, that you smear on top of a PCB and use as a mask for SMD components. As you can see here, it's really, really thick. It's basically, well, a thick paint or almost like a thin epoxy consistency. And just looking at it in the pot, it's pretty much guaranteed to not work as a spin coatable photoresist without modification. But we'll try it the first time and just see what happens. So you can see me here basically taking it, and at first I tried to drip it onto the glass slide, but that just didn't work at all. It was too thick. So I ended up just getting a big glob of it and kind of smearing it on the glass slide. And in a moment, I'll start the spinning process. And spin coating is actually a two-stage process. So the first stage, you run at a relatively low RPM, between 5 and 800 RPM. And the point of this is to physically spread the photoresist around. So all the spreading happens within that first 5 or so seconds. And then once it's spread, you crank up the RPMs up to 2 to 3,000, depending on the viscosity of the photoresist you're working with. And the point of this is not to spread it, because that already happened in the first 5 seconds. The second high RPM phase is really just to dry off the solvent. And so it's essentially an air drying phase to get as much solvent evaporated as possible. Another thing you can do is what's called a soft bake. So after you're done spinning, you throw it on a hot plate for 30, 60 seconds, and that helps bake off some more solvent. So if you look here, you can see that it just didn't work. I mean, there's no polite way to put it. It looks pretty terrible. It's thick. It's got kind of that orange peel consistency, and it didn't spread fully, which honestly, none of this is unexpected considering how thick it was in the pot. So that's not going to work. So the second run, I took the photoresist and I diluted it down in acetone. Acetone is a good solvent for photoresist. It dissolves it well. Unfortunately, you can see here that I thinned it just a bit too much. So you can actually see as I drip it on and then it starts to spread out, the photoresist looks very thin and translucent. And you can also see the acetone start to evaporate before I even start spinning it. And that's not great, because what that means is the photoresist is going to start settling out into places on the slide before I start spinning. So it won't lead to an even coverage. And as you'll see here in a second, once it spins down, that's exactly what happened. It covered thinly in places, but then there's just large sections of the glass slide that aren't covered at all. And it's hard to appreciate under this kind of low light camera work. But if you throw the slide under a microscope, you can see that the parts that did get covered don't really have a great quality to themselves either. They're pretty thin, they're patchy in places. Basically, there just wasn't enough solder mask particulate in the dilution for it to cover really well. So this was also kind of a failure, but it's looking more like what we want. So the good thing about acetone, at least, is that it does evaporate very quickly. So I'd mixed up a batch of this acetone solder paint mixture and then just let it sit for another 5 or 10 minutes and would stir it occasionally, kind of blow on it gently. And that thickened up to what you see here, which is a much, much better consistency. It's kind of a runny milk consistency, so it's slightly thicker than water. It's opaque when you drip it on, but it spreads nice and fluidly. And I think this is essentially what we're going to be going for, is kind of a slightly thicker than water consistency that's opaque. And as it spins down here, you can see that the coverage is much, much more even. It's across the whole slide. It seems to be consistent and uniform and relatively thin. It's hard to say how thick it actually is. I don't have any way to measure that. But just visually inspecting it, it looks like it's a pretty thin, even coating. It has a really nice matte texture, and you don't see a lot of obvious kind of like orange peeling. Uh, and yeah, just all in all, it looks like it's a pretty good coating. So I think this is essentially what we're aiming for. And we might have to fiddle with the initial spin parameters or the thickness of or the viscosity of the fluid, depending on how it develops under light. Maybe it's too thin, maybe it's too thick, but all in all, it looks like it's pretty good. So that's it for this stage. I'll make up a bunch more of these slides and then we'll start developing them under laser and projector light. See you next time. Thanks.